So in this segment, we'll first define the dependency parsing problem. We'll then talk about how global linear models can be applied to dependency parsing. And then finally, we'll talk about some results from work by Ryan McDonald and others, who were amongst the first to apply, actually they were the first to apply global linear models to the dependency parsing problem. So, a dependency parse looks like the following. Dependency structures are essentially an alternative form of syntactic representation from the tree-like structures we saw earlier in the course. So remember, earlier in the course we saw these kind of tree structures which were derived from, for example, a context-free grammar. Dependency structures are another way of representing syntactic information. What we have here is a set of dependency arcs. So each dependency arc is a directed arc between two symbols, which signifies that there's a grammatical relation between those two symbols, or rather those two words. So root is a special symbol. In this particular structure, I have a directed arc from root to the verb soar, because that, in a sense, is the root of the sentence. It's the main word in the sentence. I have a directed arc from soar to John, because John is the subject of soar, and that's what this directed arc signifies. I have a directed arc from soar to movie, because movie is the object of soar. And finally, I have a directed arc from movie to A, because A is a modifier, actually a determiner modifier to the word movie. Now, in the simplest case, these dependency structures are unlabeled, which means they look just like the structure I've shown you here. It's easy enough to go beyond this to have labels on these arcs, and actually that's a very natural thing to do. So in labeled structures, you might label this as being a subject, this arc as being an object arc. Maybe this would be the main verb arc, and this would be, say, a determiner arc, dt. So throughout this lecture, I'll actually stick with the unlabeled case, where these arcs don't have labels. But it's very easy to extend the techniques I'll describe to the labeled case. And in a way, the labeled case is a little more intuitive. You can see exactly how recovering these kind of dependency style annotations certainly carries a lot of useful syntactic information about the sentence being analyzed, and is in some sense quite equivalent to the parse trees that we saw earlier in this class. In fact, a little bit later I'll talk about how to directly derive these dependency structures from parse trees of the form we've seen earlier. So it'll be useful to develop a little bit of notation for dependency structures. So each dependency is going to be a pair, hm, where h is the index of a head word and m is the index of a modifier word. So whenever I have one of these directed arrows, I have a head, for example, soar, and a modifier, for example, John. So let's number these words. We always number the root as 0. So there are 4 directed arcs in this dependency structure, and that means there are actually 4 dependencies. So I have 0, 2. That's this dependency here. I have 2, 1. This dependency here. I have 2, 4. This dependency here. And I have 4, 3. This dependency here. So throughout this lecture, we'll represent these dependency structures as sets of dependencies, where dependency is an HM pair, H is the head, M is the modifier. So the dependency parsing problem, which we're considering in this segment, is to take a sentence as input and produce one of these dependency structures as the output. And again, I'm going to focus on the case where these args are unlabeled. That's the simpler case, but it's easy enough to extend the approaches I'll describe to the cases where to the case where these args actually have labels.